Hello, in today's video, we are going to derive Gaussian integral, which is quite crucial in our quantum mechanics. These integrals, we face these integrals many times. So, our aim is to evaluate the integral I equals to e raised to power minus x squared dx integration from minus infinity to infinity. So, strategy is that instead of computing I directly, we compute I square. So what we do here, we replace this x with y and uh, of course it will be replaced by dy. So we have this kind of integral. So it is similar. So we just multiply them. So we get I square like this. Now on further simplifying, we have e raised to our minus bracket x square plus y square bracket close like this term. Now it is quite easy to solve if we use polar coordinates. So what we do here, we replace this x with r cos theta and y equals to r sin theta, which means x square plus y square is just r square. And this area element dx dy, which I have written here dA, this is same. So is r dr r dr d theta. So after replacing these, we need limits for integration. So new limits for this r is 0 to infinity, and for this theta 0 to 2 pi. Now substituting these into our expression for I square, we will get like this expression. Now this is quite easy to solve. Now we separate them, like we separate this d theta to this integral 0 to 2 pi. So we left with this term r e raised to power minus r square dr, which is quite easy to solve. We just replace r square here with u, and we will get du 2r dr. Okay. Now we will after solving this, we will get like this. For this term, we have theta 0 to 2 pi, and for after replacing this term, we get this minus 1 upon 2 e raised to power minus r square integration limits from 0 to infinity. Now, this infinity term give us 0, and from this 0, we will get this half term. Now, after simplifying them, we get pi. Now, this pi is equals to I square, and our motive is to find the I. So we established that I square equals to pi. So since the integral e raised to power minus x square is positive everywhere, so I must be positive. So therefore, taking the square root of it, we will get square root pi or under root pi. Now, there is same expression. Uh, so now we generalize the solution. So now in last question we have here just minus x square term. Now we have minus alpha x square plus beta x. So how to solve this? So to solve this, in step one, we need algebraic manipulation. We need to complete the square in the exponent. So we have done these kind of question in our elementary classes. So alpha x square beta x, we can easily complete its square. So here I have done it. So first of all, we take this minus alpha term as common. So we have this x square minus beta upon alpha x. Now we need a term which we can multiply, which we can add and subtract. So we choose the term beta upon 2 alpha square, we subtract it, and same term is added. So the added term is included to uh, uh, x x minus beta upon 2 alpha square. It is quite easy. If you find confusion here, you can just comment. So now we have these two terms now, and remember they are the power we are solving for this. So now our question just changes to, oh, sorry. So step two, we rewrite and substitute the new exponent back into the integral. We have like this term. Now what you can see here, we have this plus beta square 4 alpha, which we can separate out because there is no x term with this beta square upon 4 alpha. So we pull out the constant term. Now we are left with this term. Now, what we do over here, this bracket term x minus beta upon 2 alpha, we can replace it with some other variable. So we change the variable. Let's say we choose u equals to x minus beta upon 2 alpha. So du becomes equals to dx, and a limit remains minus infinity to infinity. We have like this term. Now the same solution we have done earlier in last question. So what we know the solution of this one. So we can, but there is this alpha term. So we know the standard integral result, like minus infinity to infinity e raised to power minus alpha u square du is pi upon alpha. So this is alpha term. So multiplying this by constant prefactor, we have prefactor. We are talking about this. So we are having pi upon alpha under root, under root pi upon alpha into e raised to power beta square 4 alpha. So we have derived the following result. Uh, so if you have any doubt, you can just ask me. Thank you so much for listening me.